I just had a thought.
I think she hit the button.
I printed out your quizzes and I forgot to put the point values for the questions on it.
You mean the test? Rest in peace.
Your quiz is on Friday. 10 questions. There are some add, subtract, multiply, and divide, what we're doing today. So tomorrow, we're doing a practice quiz. Okay? The test from last Friday I'm still working on, and I still have people to make it up as well, that we're not here. Okay. I think that's everything I needed to say. 10 questions on your quiz. How many points do you want it to be worth?
100.
Okay, I'll tell you, it'll be between 0 and 100. Okay. Okay. So what have we learned so far about about complex numbers? We know this right here is called what? Standard form, and that's the way all of our answers need to be written, right? We know that whenever we encounter this guy, we have to replace it with what? And other than that, we treat it just like any other variable, right? That's pretty much the only stuff that's made it different. Today's where things get a little hairy. Let's see. Don't make fun of my jokes. That's like half my video. Okay. Sorry, needed to get some little sticky notes. Now, have you ever seen something that looks like that?
Yes.
Do you have an issue with something that looks like that?
Yes. I've seen it, but I don't know what it is.
What's the issue with something that looks like that?
It's a radical.
Other than it's a fraction, fractions just want to be treated like anybody else. What was that?
It's a radical.
It's a radical? Okay. That's part of the issue. There is one huge no-no in math. You cannot have a radical in the denominator. You can have one in the numerator, but you can't have one in the denominator. Now, does that mean that you can just flip your fraction? No, you cannot just flip it. Because if you take a fraction and you flip it, it does not mean the same thing. This is a pizza cut in 2 pieces and you ate one of them. That's a pizza that was cut in 1 piece, meaning it wasn't cut, and you ate 2 of them. Those are 2 completely different scenarios and 2 completely different looking people. So you can't just flip your fraction. Yeah, whatever. So, here's what you have to do to solve something like this. Now, you don't need to write this down if you don't want to. You would take this and you need to multiply it by something. Now, I don't want to change the value of that fraction because that fraction has a value of its own and I don't need to change that. So I need to multiply it by something equivalent to 1, which means that whatever I choose to multiply it by, I have to do the same thing on the top and the bottom so that it's just 1. Does that make sense? I'm going to multiply by radical 2 over radical 2, because isn't that just 1? But if I multiply 1 times radical 2, I get radical 2. And radical 2 times radical 2 is radical 4. And what is radical 4? So I end up getting radical 2 over 2. That's a good answer because the radical is not on the bottom. Now, why did I show you all this stuff with radicals?
Because the I.
Because what is I?
The thing.
I is technically a radical.
There you go.
Because remember this? I is equal to the square root of negative 1. So just as much as I can't have a radical on the bottom, I can't have an I on the bottom because an I is technically a radical. Is that cool?
I mean, I guess.
It's radical, right?
It's radical.
That's pretty radical.
Okay, so when we are dividing complex numbers, we're not actually going to be doing any division. all we're going to be doing is getting the I off the denominator. Okay? And I'm going from easy. I've got 2 easies, 2 mediums, 2 mediums, to 2 hard ones. Okay? All right. So, what do you notice about this guy? There's an I on the bottom. Yes? Okay. So, I am going to multiply by, guess what? 2I over 2I. Okay. So, let's see. I have a negative fraction times a positive fraction, which will give me a negative. By the way, I tend to keep the negative signs with the numerators just to stay consistent and not lose control of that negative sign. And then multiplying, I'm just multiplying across. 6 times 2i would be 12i. And 2i times 2i would be 4i squared. What do I do with the I squared? So I have negative 12i over 4 times negative 1. So continuing on, I have negative 12i over negative 4. And what is negative 12 over negative 4?
3.
Positive 3 with the I.
Interesting.
So I can still have an I in my answer. It just can't be in a denominator. Okay? So I did number 1. Number 2 is just like it. You take a minute and try number 2. I'll give you a hint. You're going to multiply by
4i.
over.
4i.
Exactly. 4i over 4i is what you're going to multiply by. Yep.
What are you laughing at me?
Shut up, Skippy.
Okay, your brain can't hurt after example number 1. Come on now.
I didn't say mine.
None of
This
that.
one's different.
Miss Frank, you want to watch me do this?
I'd rather not.
Why are you laughing at me? They're being mean to me. Bro, I'm fine.
Are you sure?
Miss Frank, you know.
I said just read the problem here.
Okay, did I start number 2 correctly?
Yes.
Maybe. Yes.
1 times 4i is,
4i.
and 4i times 4i is 16i. So that's really 4i over 16 times negative 1, which is 4i over negative 16. And what does 4 over 16 reduce to?
To a fraction.
So use your fraction button, and you'll find out it reduces to 1/4.
I know, but you said there can't be I on the side.
So I have a 1i over negative 4 as my answer.
It's just I over negative 4.
Uh-huh.
Love, I think I'm getting this, guys.
It should be. Oh, you did better than that.
Now I will get people that ask me, can I put the 1i? We talked about that a little bit. Yes, you can.
It's not. It's not. It means you're not smart.
Yeah. It's a little, yeah. Okay. You okay on ones like that where it's just a simple top, simple bottom?
Wait.
Now, I kind of wish I did these in a little bit of different order. I'm going to jump down and do 5 and 6 first, and then I'll come back to 3 and 4.
Okay.
Because 5 and 6 have similar denominators to what I just did.
Okay.
You see that? What's different about 3 and 4, by the way?
They have extra numbers.
They have extra numbers. And boy, did I choose bad examples. Look at that. They have the same denominator.
I know, that's whack.
Okay.
Oh, yeah, they do.
All right. So number 5, again, it's okay to have an I in the numerator. It's not okay to have an I in the denominator. So what am I going to multiply by? Negative 10i and negative 10i.
Like this.
So, if I look just at the denominators right now, just there, I have positive 100 I squared, which will become what?
Negative
100 times negative 1, which will become negative 100, right? And I'm running out of room, so I'll deal with that in a minute. So let's see, negative 100. All right, now let's look at our numerators. I have one term being multiplied by two terms. So what do you think I need to do? I need to put that in parentheses and distribute. So negative 10i times 8 would be negative 80i.
Jerry, get the footage.
And negative 10i times 2i would be negative 20i squared. So let's look at that a little bit further. Negative 80i minus 20 times negative 1,
Yeah.
which will become what? Positive 20? That will become positive 20, correct? So I'm going to call that 20 minus 80i. Now, I'm not quite done. Do you notice that 20 and 80 could both be reduced over 100?
Yes.
So, as soon as you notice that either one or both of those numbers can be reduced, we need to split it up into two fractions like we did before. So I'm going to call it 20 over negative 100 minus, you use whatever this sign is, minus 80 over negative 100 I. So what is 20 over negative 100 reduced to? 20 over 100, 2. Sorry. Come on, Franken. 20 over 100 is 1/5. So I have 1 over negative 5 minus, what about 80 over negative 100 is 4 over negative 5. And there's my I.
That's a little confuzzling.
I mean, it's not hard.
You should be good up until here,
Yeah.
right? You should be good up until there. And then we're just splitting it apart and reducing those fractions.
That's not too bad.
Okay?
The next time it's going to be wrong.
Can I throw one last comment in there for those of you that understand what I just did?
Yeah, sure thing.
If you understand what I just did, you actually would never see minus a negative. What would it be? It would be a plus. Because minus a negative
Yes.
makes a positive. So you would actually see this as 1 over negative 5 plus 4 over 5i. In fact, you know what? I would prefer that way.
You get extra points that way.
No, you get points that way. You work on original credit before you talk about extra credit. So again, why did that become a plus sign? Because this negative sign means that that entire fraction is negative. And when you are subtracting a negative, it becomes a plus. So I should not have boxed that. So pretend like that's not boxed, okay? We'll just pretend that that's not boxed.
I'm gonna do that too.
Oh, wait, never mind.
So?
So.
Okay. Let's try number 6. What am I going to multiply by?
6i.
Over
6i.
6i over 6i. So if I look at the top, I'm going to have to distribute, right?
Yep.
So 6i times 8 would be what? 48i. And 6i times I is
6i squared.
6i squared. On the bottom, I have 6i times 6i, which is
36i squared.
36i squared. So let's replace those I squareds with what?
Just the minus
The negative 1. So let's see, this right here ends up being negative 6. So I have negative 6 plus 48i over negative 36. Everyone okay with how I got to there?
Yeah.
Okay. Do you notice that 6 or 48 will divide by 36?
Yes.
And you can reduce that. By the way, if they can't, like let's say this was 37, which is a prime number, then I'm just done right there. I don't need to split it up. But if it can be reduced, we have to separate it. So let's see. Negative 6 over negative 36 plus 48 over negative 36i. Actually, you know what? I want you to split it up. Even if it doesn't reduce, I want you to split it up.
Okay.
Because if you don't split it up, it's technically not in a plus bi form. Right? All right. Negative over a negative becomes a what?
Positive.
Positive. And 6 over 36 reduces to
1/6.
1/6. You can do that on your calculator if you want to. Now, I am adding a negative. What does that mean? Adding a negative turns into subtraction. And let's see. 48 over 36. 1 1/3. I'm going to hit second and then my fraction button again. It reduces to 4/3 I. In other words, I believe they divided by 12 on top and bottom.
That's not too bad.
Okay? So again, this will be saved on YouTube for all of you who want to go back and hear it again. Okay? All right. Now let's go back to numbers 3 and 4. 3 and 4 are very similar to 7 and 8. How are they similar?
Because they're median.
The denominators have 2 terms, don't they? Yes? 3 and 4 are a little bit easier because what do you notice about the numerators? In 3 and 4, there's only 1 term in the numerator. All right, so I have to talk to you about something called, where did all my little sheets of paper here go? A conjugate. Okay, here's what a conjugate is. It is changing an addition problem to a subtraction problem, or changing a subtraction problem to an addition problem. So for example, if I gave you 4 plus 5i, guess what the conjugate is? 4 minus 5i.
So conjugate is opposite.
If I gave you 2 minus 3i, guess what the conjugate is?
Less than
What if I gave you negative 4 plus I? What's the conjugate?
4.
Careful.
No, it's negative 4 minus I.
It's negative 4 minus I. You don't change the sign. Why did I put a parenthesis there? You don't change the sign of the term of the first term. You just change the addition to subtraction or the subtraction to addition. Excuse me.
Keep the sign.
Why do I tell you that? Because
We're going to do that.
in order to get the I off the bottom here, I can't just multiply by 10i. I have to multiply by the conjugate of 3 plus 10i. So what is the conjugate of 3 plus 10i?
3 minus 10i.
So I have to multiply by 3 minus 10i over 3 minus 10i. From here, it's exactly the same. I'm going to look at the numerators, multiply them, look at the denominators, multiply them. What's a little trickier with this one is if I look at the denominators there, I'm going to have to FOIL.
So
You see that? I'm going to have to multiply like I did on last night's homework. Up here, 1 term times 2 terms, that's just distributive property.
okay.
Okay? There's just a little bit more multiplying steps. But that's it. So let's see. On the top, 3i times 3 would be what?
9i.
And 3i times negative 10i?
30i squared.
Negative 30i squared. Yes?
Yep.
On the bottom. Actually, you know what? I don't want to confuse myself. I'm just going to finish the top as far as it'll go. Then I'll go to the bottom. As opposed to going bottom, top, bottom, top, bottom, top. Okay? So, 9i minus 30i squared. The i squared needs to be replaced with what?
A negative 1.
So I have minus 30 times negative 1. What does that become? Positive 30. So what's that going to simplify to? 30 plus 9i. So that's my numerator, as simple as it'll go. Yeah?
Yeah.
Now let's multiply our denominator. So let's see. 3 times 3 is 9. 3 times negative 10i is negative
30i.
positive 10i times 3 is
30I.
positive 30i. And positive 10i times negative 10i would be negative 100i squared. Now, if you have the correct conjugate, then what's nice is these two middle terms will always cancel each other out. That's how we're getting the I off the denominator. So what does that leave me with? 9
Plus.
minus 100i squared, but I'm going to replace the I squared with negative 1. And this is positive 100?
Yeah.
And 9 plus 100 is?
109. Oh wait. Oh shit.
No, you're right.
Really?
Apparently I'm getting really excited and wanting large numbers. 109. All right, last thing I need to do, split it up. 30 over 109, which I don't know if I can do anything with that.
I don't know.
30 over 109, nope,
Oh, so you leave it?
plus
I don't know.
9 over 109. Can that reduce? Nope.
So what happens?
I. So what happens? That's my answer.
Really? We still have to split it for next?
Yes, because that way it's in the A plus BI form.
Okay. Wait, so if one reduces, you're only reduce one of the fraction?
Yeah.
Okay.
Always split it up and then treat them as two individual things that either both reduce, one reduces, none of them reduce. Okay? All right, number 4, which was kind of lame of me to choose the same denominator, but I didn't notice that, so we'll deal. What's the conjugate of 3 plus 10i? 3 minus 10i. Okay, so you take a minute on that one. Throw your parentheses around because you're going to be distributing and foiling and whatnot, and see what you can do on that one. Okay, so let's see. I have 3i minus 30i squared on top. Yes? Which is going to be 3i minus 30 times negative 1.
Wait, how'd you get 30? How'd you get 30?
I don't know because I can't multiply.
It's 10.
Yeah?
I made the same mistake. You Miss Frank in our audit today.
3i plus 10. I really should write that the other way, shouldn't I?
Yeah, but it's okay.
It's not okay. It's not standard form.
Is today your off day?
It must be.
I wrote it backwards too.
So I'm going to write 10 plus 3i. There we go. Okay. I have 9. You know what? Since I have the same denominator, can I save myself some work?
Yeah, I saved myself.
Didn't I already multiply it and simplify it? What does it end up being?
109.
109. So we'll just ignore those ones. So let's see. 10 over 109 plus 3 over 109i. And I'm pretty sure, well, 10 is not going to reduce, right?
I wrote it different. My bad.
Right? 10 over 109. And then 3 over 109 does not reduce. So I am done. You're welcome for giving you the same denominator. Okay. You ready for the last ones?
Yeah.
So 7 and 8 are done exactly the same way. What's different? Is there another notes page, please? What's different is that you're going to have to FOIL on both the top and the bottom.
Oh, Lord.
Because the top has 2. Now, because I was kind of squishing my room there, I am going to actually give myself some more paper here.
That's cheating.
Nope. What am I going to multiply by here? 3 plus 8i over 3 plus 8i. Yes?
Yeah.
Now, I'm going to have to FOIL on both the top and the bottom. So do you see why it was important to do multiplying first? because it's the conjugate. Remember the conjugate, you change it from a subtraction problem to addition, or addition to subtraction. Okay? So let's see. Negative 5 times 3 is negative 15. Negative 5 times 8i is negative 40i. Negative 9i times 3 is negative 27i. And negative 9i times 8i would be negative 72i squared.
Does it say negative 27?
Huh?
Does it say negative 27?
Yes, it does.
Yes.
Hey, geez.
Okay. So negative 50. I'm going to simplify this as far as it'll go, and then I'll do the denominator, and then I'll put them all together. Capiche? Let's see. Negative 40 and negative 27 would be negative 67i minus 72 times negative 1. What does that end up being? Positive 72. So I have negative 15 plus 72. Is that, I think that's 57. Check me if I'm wrong. Negative 15 plus 72. Boom, 57 minus 67i. You okay with that?
Yeah.
Okay, that's my numerator. My denominator, let's look at that. 3 times 3 is 9. 3 times 8i is 24i. Negative 8i times 3 is negative 24i. And negative 8i times positive 8i would be negative 64i squared. Again, if you did the correct conjugate, those middle terms drop off.
Yeah.
So you have 9 minus 64i squared. What do you replace the I squared with?
A negative 1.
So that becomes what?
9.
9 plus 64, which is what? 73.
Yes.
66.
It's 1 less than 10 plus 64, right?
Yeah.
So if I break this up, 57 over 73, I doubt that's going to reduce, but we'll check. Minus 67 over 73. There's my A plus BI form.
Yeah, that's not going to reduce.
57 over 73, I'm 99% sure. I'm just going to verify,
I'm 100% sure.
because knowing me, those are those stupid points that I always lose. So I'm done right there. This is as hard as they could possibly get. I can't make them any harder than this. Okay? Now, I don't know. How much time have we got? We're doing okay. All right. So what is my conjugate that I'm multiplying by here? Negative 3 minus I. Remember that first term you do not change the sign of it. Only the middle do you change. Okay, so let's go ahead and do our multiplying here. I'm going to multiply numerators first. 3 times negative 3 is negative 9. 3 times negative I would be negative 3i. 3i times negative 3 would be negative 9i. And 3i times negative 1 is negative I, not negative 1. I squared. So I have negative 9 minus 12i minus 3 times negative 1. Yeah?
Yep.
Negative 3 times negative 1, that's going to become a positive 3. What's negative 9 plus 3? Oops, negative 6. And then I have a minus 12i. And then on my denominator, that's the one where things will cancel out. Negative 3 times negative 3 is 9. Negative 3 times negative I is positive 3i. Positive I times negative 3 is negative 3i. And positive I times negative I would be negative I squared. Yes? Now be careful here. This one's a little tricky. The middle terms do cancel out, but I have 9 minus I squared. That would be minus I squared. Looks like that. What happens? It becomes to 9 plus 1, which is 10. So let's split it up and reduce. Negative 6 over 10 minus 12 over 10i. What does negative 6 over 10 reduce to? Negative 3 over 5 minus, if I cut these in half, I get 6 over 5. And that's my answer. Okay? So your homework has an assortment of all of those levels of difficulty there. Okay? Happy studying.